सभी आ गए? Very good. Try to answer this question. Find ratio of tensions T1 and T2 in two parts of string. बच्चों नॉइज तो नहीं आ रहा है बाहर से?
No, sir.
Okay. So this is they are rotating with constant angular velocity omega. Let's say this is m1, and at midpoint you have m2. This is midpoint. Here tension is T1 and here tension is T2. What is T1 by T2? Suppose they have constant angular velocity omega. What will be the ratio of tension? Anyone? Hint is net force acting towards center. Hint is net force acting towards center will provide centripetal force. Will provide centripetal force. First basic. Second basic, tension is always going away from the body. Tension is always going away from the body. Third, in one string, tension is same everywhere. बच्चों M1 और M2 के बाद फिर ये अलग धागा है, ये धागा अलग है. ओके, तो अब now imagine yourself on M2. सपोज आप M2 पे खड़े हैं तो, और ये वाला जो ब्लू वाला स्ट्रिंग है इसमें टेंशन T1 रहेगा अवे. आप समझ गए T1 दूर क्यों जा रहा है M2 से? Because tension always have two directions. तो M1 से तो दूर जा ही रहा है. आप देख सकते हैं M1 से दूर जा रहा है ये T1. जब आप M1 पे अपने आप को मानेंगे तो T1 का डायरेक्शन आपको दिख जाएगा. लेकिन जब आप M2 पे मानेंगे तो T2 और T1 दोनों ही दूर जा रहे हैं. यहां तक कोई डाउट? Any doubt till this? Now the last and the most important basic, to rotate a particle of mass m in circle of radius r, force required towards center is, बताएं जल्दी. How much force is required towards center? जल्दी. m omega square r or m v square by r. I think this is better. But this one suits perfect in this case, right? पूजा मैडम चैट फैकल्टी तो कर रही है, उसको ये याद रखना पड़ेगा ना. चैट फैकल्टी कर दीजिए प्लीज. कभी हमेशा कर दिया करिए प्लीज. Okay, now look at only M1. Look at only M1. How much force M1 need to perform circular motion? Let's say this is L. Let's say this is L. Give me a minute, बच्चों. Okay, now the net force acting towards center on M1 is what? How much force is acting on M1 towards center? net force on M1 acting towards center. Come on. बोलो जल्दी. किसी को आंसर देना है कि नहीं देना है? आवाज आ रही है मेरी आप सबको?
यस सर।
तो M1 पे सेंटर की तरफ कितना फोर्स लग रहा है? 11th वाले बच्चों समझ नहीं आ रहा है आपको? T1 अकेला लग रहा है. This is horizontal circle and this is center of the circle. This आप में से किसी से नहीं बन रहा ये? The only force acting on M1 towards center is T1. So this is net force and this will provide centripetal force M omega square L. Understood or not? Everyone respond. Everyone understood? Click on yes. Everyone click on. Everyone immediately. Okay. Now look at M2. Can anyone predict what net force is acting on the M2 towards center?
T2 minus T1.
Yes sir, T2 minus T1.
हाँ, ऐसे तुरंत जवाब देना है ना. So net force on M2 towards center, because T1 is acting towards center and T2 is away from T1 is away from center, so T2 minus T1, and this net force will provide M2 omega square. This must be M1. M2 omega square L by 2. Am I right?
Yes.
Am I right, bachcho?
Yes.
Now, put value.
Yes,
Let's
sir.
put value of T1 M1 omega square L is equal to M2 omega square L by 2. So you got T2 as M2 omega square L by 2 plus M1 omega square L. T2 is equal to omega, you can take omega square L common. You got M2 by 2 plus M1. So you got value of T2 as omega square L M2 plus 2 M1 whole upon by 2. Understood? This is our equation C. You want ratio of tension. So they want T1 by T2. So T1 is M1 omega square L. T1 by T2 M1 omega square L divided by omega square L M1 plus 2 M1 divided by 2. Omega square L got cancelled. 2 ऊपर चला जाएगा. So 2 M1 upon M1 plus 2 M2. Hopefully you understand this.
Yes.
Okay.
Yes, sir.
Now learn this again. Net force acting towards center will provide centripetal force. A very important concept. Okay, ready for the next question, everyone? Shall we move towards? Okay. Copied this one. Take a screenshot. If you could not copy, take a screenshot and make it fast. Okay. Now I can read your message. Harj, Vidhi, now I can read your messages. My laptop started. Question number 2. A very good question, but a very easy as well. A small block slides with velocity 0.5 root gr on horizontal frictionless surface as shown. The block leaves the surface at point C. Calculate angle theta. As shown in figure. I told you to solve all the questions again, which we discussed in the last class. Hopefully, you all did that. किया या नहीं किया? आपने किए थे क्वेश्चन दोबारा या नहीं? कुछ पूछ
Yes,
रहा
sir.
किए थे ना? हाँ. This is O, center. Imagine this is a block moving forward with velocity v naught. Moving forward with velocity v naught at point A. This point is B, and will leave surface at this point. This point is, let's say, C, which makes an angle theta with the vertical. Okay. You can see point C from where this block will leave the surface. You know why this block will leave surface here? Can anyone explain how block is going to leave surface?
Centripetal force will not be
Centripetal
sufficient.
force sufficient.
Okay. Okay. So what velocity of the block at this point should be v naught, less than v naught, or more than v naught? Velocity at point
More
C.
than V naught.
More than v naught, correct, because potential energy is decreased. So if you want, we can assume this as our ground, our reference point. Can we consider this as a reference point? Yes or no?
Yes, sir.
Yes.
Reference ध्रुव, reference मान लिया तो यहाँ पे potential energy क्या हो जाएगी? If this is the reference point, what is potential energy at C? Okay, so potential energy at C is 0, and kinetic energy at point C is 1 by 2 m Vc whole square. Okay, can you help me in writing potential energy at point A? What is potential energy at point A? What is this height? This is R. This is R cos theta.
R minus R cos theta.
R minus R cos theta.
Correct. So this height is R minus R cos theta. This is H. So what is potential energy at point A? R minus mgh. mgh and mg R common 1 minus cos theta. And what is kinetic energy at point A? 1 by 2 m v naught square. Okay, now what is going on in your mind now? What we can do? What picture is running in your mind now? What we should do now?
Energy consumption.
Okay. Now let's say from conservation of total mechanical energy. So total energy at A must be equal to total energy at B, assuming all the resistive forces are absent. So total energy at A is mgr 1 minus cos theta plus 1 by 2 mv naught square is equal to potential energy at point B is 0, because we assumed it as our reference point, and kinetic energy at point B is 1 by 2 mvc square. Okay, we can take m common and cancel. Let's multiply both the side by 2. So 2 got cancelled. Okay, तो इससे हमें क्या मिल गया? Velocity at point C, right? We got velocity at point C. क्या देख पा रहे हैं आप लोग? We got velocity at point C. This is first important information we got. Now we have velocity at point C. Now who will suggest me what is use of velocity at point C? What is use of velocity at point C? Come on, tell me. जल्दी बताएं. अब क्या करने आदेश? क्या तुमने सिर्फ कंजर्वेशन ऑफ एनर्जी सीखा है इस तरह के क्वेश्चंस में, या एक और कंसेप्ट सीखा है? Is there is any one more concept do you have?
Yes, sir.
What is that? What is that? Tell me another concept.
Total energy.
Total energy we used. There is one more concept we can use here. Tell me what is that? जल्दी. सब गधे हैं, सब एक से बढ़ के एक है, सब बिल्कुल एक ही. कुछ भी वर्टिकल सर्कुलर मोशन पढ़ाया मैंने अभी तुम लोग को? नाउ से नेट फोर्स
What energy?
नहीं लग गया, सब लग गया. नाउ से नेट फोर्स एक्टिंग टुवर्ड्स सेंटर विल प्रोवाइड सेंट्रीपिटल फोर्स. से
Net force acting towards
As for providing towards centripetal.
will provide centripetal force.
centripetal.
Centripetal.
Why? क्यों भूल रहे हो तो इसको? क्यों भूल रहे हो ये चीज? अब नहीं भूलेगा कोई? बोलो अब नहीं भूलेंगे? बोलो
Yes.
सब.
Yes, sir. अब नहीं
Sir.
भूलेंगे.
हाँ.
Yes.
तो अब now let's take two component of mg. What will be this component?
mg cos theta.
बहुत बढ़िया. This is mg cos theta, and you can make one more component of mg. What is this component?
mg sin theta.
Mg sin theta.
Okay, and what is missing?
Normal.
Okay, who is this? Who said normal? What is name of this student?
Devraj.
Devraj, very good. This is normal. So can you predict what is net force towards center of the circle?
Mg cos theta minus n.
Huh? Net force towards center. You said mg cos theta minus n.
Yes, sir.
So is equals to centripetal force.
Absolutely correct. Mg cos theta minus n will provide what?
Centripetal.
mv square by r.
Okay. Now because block lost contact. Now tell me, because block lost contact, so what should be the value of normal reaction? अगर आपके पैर जमीन पे टच ही नहीं है तो normal reaction कितना आएगा?
0.
You see,
Zero.
they are not touched. They are not touched. So what should be the normal reaction? 0. Normal reaction must be 0. Mg cos theta is equal to m by r into Vc square, and we have value of Vc already. Let's put value of Vc square. रखें?
Yes.
Yes.
Yes, sir.
Vc square की बड़ी सी वैल्यू रखनी पड़ेगी हमें. ये वैल्यू वहां ले जाने, मेरी मदद करो. Let's copy this. Okay, let's put value of Vc square. क्या मिलेगा हमें? V naught square plus 2gr 1 minus cos theta. ये लो. And it is given in the question, बच्चों. Sorry, I am telling you this, Nate. Given in question. This from the NEET module. V naught is equal to 0.5 under root gr. So what will be V naught square? Gr by 4. Okay. Say yes.
Yes, sir.
Yes, sir.
Now put
Yes,
these
sir.
values. Put these value. Mm got cancelled. G cos theta. R. Let's transfer R other side. V naught square means gr by 4 plus 2gr 1 minus cos theta. Now let's solve this. Well, let's multiply gr into the bracket, multiply both the sides by 4. Get 4 gr cos theta plus gr. 4 gr cos theta is equal to gr plus 8 gr into 1 minus cos theta. You can take gr common and cancel. So you got 4 cos theta is equal to 1 plus 8 minus cos theta. 8 minus 8 cos theta. So you got 12 cos theta is equal to 9. So cos theta is equal to 9 by 12. 3 by 4. So you got theta is equal to cos inverse 3 by 4. It's a very good question, level 1 question. It will never ever come in any school exam. Such questions will never come in the school exam. But I believe you understood this and you all are able to solve such questions. Am I right? Everyone understood this clearly? Yes or
Yes,
no?
sir.
Yes, sir.
Yes, sir.
That's good. Now we can solve these type of questions. Everyone copied? आगे बढ़े?
Yes, sir.
अर्पित कोई डाउट तो नहीं?
No, sir.
ओके तो अभी इस क्वेश्चन में भी हमने क्या किया? दो चीजें की. कंजर्वेशन ऑफ एनर्जी. ओके, दिस वाज गिवन इन द क्वेश्चन. ओके, conservation of energy and conservation and the second thing is net force towards center will provide centripetal force. Okay, these are the two concepts which we are working on entire this chapter. अब हम अगले कंसेप्ट की तरफ बढ़ते हैं. उसके पहले एक क्वेश्चन, इट्स अ वेरी इंपॉर्टेंट क्वेश्चन. A tube of length L is filled completely with an incompressible liquid of mass M. Very important question. A tube of length L is filled completely with an incompressible liquid of mass M and closed at both the ends. The tube is then rotated in a horizontal direction, in a horizontal plane, I'm sorry, in a horizontal plane with uniform angular velocity. The force exerted by the liquid at the other end is the force exerted by liquid at other end of rod. M L square omega by 2. Second, M omega square L by 2. Third, M L omega square. Fourth, M L square omega square by 2. तो पहले तो 50-50 तो डायमेंशंस देख के हो जाएगा. It should be M omega square R. So this cannot be the answer. M omega square R. So this cannot be the answer. So 50-50 तो डायरेक्ट हो गया. Now tell me what is your answer. Let's make a tube. Perfect tube चाहिए अपने को क्या? This is a tube which is being rotated with constant angular velocity omega about this axis. This is water, blue है पानी पानी. Water is completely filled in this tube. And the length of the tube is L. Am I audible?
Yes.
Shreya gave correct answer. Because this is matching with the EMI chapter. Dhruv कैसे किया?
Some centripetal force.
Okay. नहीं तो by 2 कैसे आया तेरा?
M ओमेगा स्क्वायर L by 2 और सर उसका हो जाएगा हाफ M ओमेगा स्क्वायर L.
नहीं समझा नहीं मैं.
इंटीग्रेशन से.
इंटीग्रेशन से आएगा या you can assume entire mass at center.
Entire mass center.
हाँ, if you can assume entire mass at the center, so the distance is L by 2. So centripetal force required is m omega square L by 2. This much force is required towards center. So liquid is try to go outside of this tube. Am I right? So from here to liquid will get normal reaction by the tube. Could you understand that? And this normal reaction will provide centripetal force. So answer is this. But still, if you want to calculate it by not by shortcut, if you want to calculate it everything properly, then you should not do this. If you want to calculate it properly, see this. What you'll do? We'll take an elementary point mass. Suppose this is dm, and width of this is dx. Suppose its width is dx, and its mass is dm, and its position from the axis of rotation is x. So now you can tell me what is the net force towards center required for this point mass. How much force towards center is required for this point mass? I am writing DFC because it is a very small centripetal force. क्योंकि मास बहुत कम लिया है, हर्ट्ज मास बहुत कम लिया, इसलिए हमने उसको DF माना है. अब तुम पूरे ट्यूब को नहीं देखोगे, अब तुम सिर्फ DM को देखोगे. Everyone look at DM as a point mass. What is DM? Point mass. Okay, now so how much force is required? How much centripetal force is required for DM? DM omega square x. Any doubt? Please tell me if you have any doubt. Adesh, Arpit, Dhruv, Devraj, Shruti.
No, sir.
Okay. My all
No,
having this are comfortable? Okay. Now integrate both the side. So you will get net centripetal force. You can integrate here. The problem is by omega square will come outside. It is a constant. We cannot integrate x by dm. We can integrate x by dx. So how we can bring dx in the picture? Harsh doubt hai? How to bring dx in the picture? I have a clue. L length का mass m है. Mass
M by L dx.
L length is m. अगर L length का mass m है, so what is mass of unit length? What is mass
M
of
by L.
m by L? Okay, this is mass of one length, m by L. So mass of one length, m by L. Mass of two length? Mass of two length? 2m by L. Mass of three length? 3m by L. So mass of dx length? Mass of dx length? m by L into dx, which is जो कि dm की वैल्यू है. तो dm की जगह ये रख दो, तो आपको मिलेगा ओमेगा स्क्वायर बाहर आ चुका है, x dm की जगह आ जाएगा m by L dx. 0 से L, because main variable is x and the value of x is from 0 to L. Am I right? देखो x बदल रहा है ना. The minimum value of x is 0 and the maximum value of x is L. फिर से कांस्टेंट बाहर आ जाएगा. Omega square m by L will come outside, and when you integrate x with respect to x, what you will get? पावर एक बढ़ जाएगी, you will get x square by 2. Am I right? Now you put limit, you will get centripetal force required is m omega square by L into L square by 2 minus 0. So final answer is L and L will get cancelled. You will get m omega square L by 2. This is long method, full conceptual method. I believe no one has any doubt now. Everything is clear now?
Yes, sir.
Yes, sir.
This is from AIPMT 2006. आगे बढ़े?
Yes,
आगे
sir.
बढ़े? Okay.
Yes, sir.
Yes, sir.
Three identical particles joined together by a thread as shown in figure. Velocity of the outermost particle is V naught. Velocity of the outermost particle is V naught. Then the ratio of tension in these strings will be see, this is the quotient, this is point O, this is A, this is B, this is C. Okay, they're performing circular motion in a horizontal circle. Horizontal circle में घूम रही बच्चों, ignore mg. Okay, समझ गए?
Yes, sir.
Yes, sir.
Assume here tension is Tc, here tension is Tb, and here tension is Ta. Okay. And suppose this is rotating with a constant angular velocity omega. Can you tell me what is value of Tc? What is value of Tc?
Omega square 3L.
Very good, very good. Net force acting towards center on C is m omega square 3L. This will provide centripetal force. Everyone understood this? Anyone have any
Yes,
doubt?
sir.
Anyone have any doubt? No doubt? Now imagine yourself on B. So TC will be going away from the B. Am I right? So what is
Yes.
net force? What is net force acting towards center on B?
TB minus TC.
Omega square 12.
TB minus TC. आवाज नहीं निकल रही, खाना नहीं मिला है?
Omega
हाँ?
square.
मम्मी पापा दिन भर मेहनत करके खाना देते हैं, तुम लोग की आवाज पढ़ाई करते समय निकलती नहीं है। नालायक सबके। आंसर देने के लिए आवाज नहीं निकलती, मन का खाना खाने के लिए और जो कोई चीज चाहिए, मोबाइल चाहिए तो चिल्ला चिल्ला के बात करोगे पेरेंट्स से और मुझसे। TB माइनस TC कितना हो जाएगा m ओमेगा स्क्वायर 3L is equal to m omega square 2L. So what is TB?
M omega square 5L.
5L. This is equation number B. Now find TA by your own. Everyone try to find TA by your own. Assume yourself at A. Assume yourself at A. Where is TB?
M omega square 6L.
Where is TB going first? Tell me this. Away. So net, I think you are correct. So net force towards center, TA minus TB is equal to m omega square L. So what is TB? 5m omega square L. एकदम करेक्ट आंसर है तुम्हारा. So TA is 6m omega square L. Understood this?
Yes, sir.
Yes, sir.
Yes,
कोई
sir.
डाउट मैं नए तरीके से भी समझा सकता हूँ. If anyone have any doubt, I can teach you in a new way. No one should have any doubt in this. सब समझ गए? So what is tension TA, TB and TC? 6m omega square L, TB 5m omega square L, 3m omega square L, m omega square L, m omega square L, m omega square L got cancelled. So we are getting 653. TA maximum, then TB, and then TC is minimum. Understood, बच्चों? Confidence
Yes,
आया
Yes,
कि
sir. मजा आया कि नहीं आया? खुश हो कि नहीं जीवन में? 8 बच्चे
Yes,
खुश.
sir.
खुश रहना ही है. मुझसे पढ़ के खुश रहना है. मुझसे पढ़ के भी खुश नहीं है तो फिर मेहनत करके खुश होना है. वो प्रॉब्लम सॉल्व करके खुश होना है ना? होमवर्क करके खुश होना है. A stone is tied to a string of length. देवराज तेरे बुक का एक्सरसाइज 3 का क्वेश्चन है. Length and is drilled in a vertical circular motion. At certain instant of time, the stone is lowest position and has a speed u. Find magnitude of change in velocity when it reaches a position where string becomes horizontal. Yes. Copied? Take your time. Let's read the question and let's try to make a diagram. What is happening? A stone is tied to a string of length and drilled in a vertical circle with the other end of the string at center at a certain instant. The one time the stone is okay. At lowest point its speed is u. Means at this point its speed is u. They want change in velocity of this when it reaches or when the string become horizontal. Let's say velocity is v. Okay, and the length of the string is l. समझे भाई लोग?
Yes, sir.
Yes.
इसको reference मान लें. Suppose this is a reference. So we can find v. V we don't know. We can find value of v by what? By conservation of energy. Okay. This is point B, let's say, and this is point A. Potential energy at point A, tell me. 0. Kinetic energy at point A, tell me.
Half mv.
M square. What is potential energy at B?
And
Wow.
v
What is the kinetic energy at B?
half mv square.
By 2 mv. With V we don't know, but from the conservation of total mechanical energy, we can write total energy at A and total energy at B must be equal. So 1 by 2 mu square must be equal to mgl plus 1 by 2 mu square. समझे? Huh?
Yes, sir.
So mv square, sorry. Huh? So you can calculate VL V square very easily if you transfer GL other side. So you got V square by 2 and there you have a 2. Let's multiply both the side by 2 before doing anything else. Let's multiply both the side by 2. ये V है, हाँ V है, ये गलती से U लिखा गया है. So this is total energy at A and this is total energy at B. Multiply both the side by 2. 2GL plus V square. So U square minus 2GL under root barabar V. Understood or not? Huh? So what is change in velocity?
Yes, sir.
What is change in velocity? Final velocity है Vj or initial velocity है Ui. Because when you talk about velocity, you cannot write velocity without taking vector into account. Am I right? Vector के बिना velocity थोड़ी लिख सकते हो. Could you understand that?
Yes, sir.
Okay.
Yes,
Change
sir.
velocity everyone could understand. Okay, now let's put value of V. This is V2 minus V1 or velocity at B minus velocity at A. So you get U square minus 2GL J cap minus UI cap. But they want magnitude of this change in velocity. VB minus VA. अब क्या करें? बोलो सर अंडर रूट आई के कोफिशिएंट का स्क्वायर बोलो. अंडर रूट आई के कोफिशिएंट का स्क्वायर प्लस जे के कोफिशिएंट का स्क्वायर. Could you understand that?
Yes, sir.
So your final answer is U square plus U square minus 2GL. So U square 2U square minus 2GL. 2U square minus 2GL. You can take 2 common. U square minus GL.
Minus.
This will be the magnitude of change in velocity. This is not only change in velocity, this is magnitude of change in velocity. I believe everyone understood. This
Yes.
was a good question. This was a good question. Good, very good question. Level was good. Okay. अब हम शुरू करते हैं थोड़ा सा पढ़ाई वर्टिकल सर्कुलर मोशन. Right topic, vertical. Done? Copied? Most of the
Yes.
students, yes. So we are starting vertical
Yes.
circular. Huh? So वो सर आने वाले ना फीस देने. पता नहीं कब आएंगे. लिखो vertical circular motion. बच्चों अब ये होता क्या है? Suppose a mass m is attached with a string of length L. Suppose a mass m is attached with a string of length L and it is whirled in the vertical circle. Okay, vertical circle में इसको गोल 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 घुमा पा रहे हैं. इसको अपन कंप्लीट वर्टिकल सर्कुलर मोशन तब बोलेंगे जब ये पूरा चक्कर लगा लेगा. ओके बच्चों, समझे? या अब आप इसको ऐसा बोल दें कि वर्टिकल सर्कुलर मोशन में अज्यूम कर लें कि पार्टिकल विल कंप्लीट वर्टिकल सर्कल, है ना? Assume particle will complete vertical circular motion if we give minimum speed v is equal to Bob. Okay, can you tell me how much speed we can give to mass m? How much speed we should give to mass m so that it perform vertical circular motion? What minimum speed we should give to m so that somehow it's perform vertical circular motion? Let's assume how much speed? V or V minimum. V is okay. Huh? Okay. Suppose you have given V speed to this particle in order to make it rotate in a complete vertical circle. Now assume it started rotating and after some time it reached at the topmost point of the circle. Suppose this is the topmost point of the circle and somehow it just managed to reach at this point. Reach at that point. This is point A and let's say this is point B. Okay. And if you assume velocity at B is 0, then particle will fall downward and it won't be able to complete circular motion. Could you understand that?
Yes, sir.
अगर आपने B को रोका हुआ मान लिया तो वो सर्कुलर मोशन करेगा या वहीं से नीचे गिर जाएगा श्रुति?
नीचे गिर जाएगा.
नीचे गिर जाए.
So if you want to complete circular vertical circular motion, this mass should have some velocity at B or not?
Yes, sir.
Let's say at this point velocity is VB. Okay, so let's assume at B velocity is VB. Okay, now let's represent all the forces and always do this step. Let's represent all the forces. This is mg and this is TA because this point is A, and here tension is TB because this point is B and mg is acting here. Wow, mg can provide centripetal force as well at point B. Could you understand that? Okay, now let's assume this as reference point. ध्रुव A को reference point मान ले बच्चे.
Yes, sir.
Reference point. तो ये हाइट कितनी हो गई टोटल? 2L. So what is potential energy of A? Kinetic energy of A half mv. VA मान लेते इसको, ठीक है? Okay. What is potential energy at B?
mg2.
What is kinetic energy at B? VB square. Right? Can I say these two energies are equal? sum of these two energies are equal. Total energy at A is equal to total energy at B. Can I say this? Yes or no?
Yes, sir.
Okay, so from conservation of energy, let's write 1 by 2 mVA square plus 0, and total energy at B is 2 mgl plus 1 by 2 mvb square. Take m common and cancel. Now multiply both the side by 2. You will get a relationship between VA and VB. 4gl plus VB square. Any doubt in this?
No, sir.
Okay, so you got a relationship between VA and VB. We can uncast this relationship. We can use this relationship, but the problem is that we don't know VA and we don't know VB. हमारे पास दो unknown है. It means we need more equations. So how I can make more equations? Please give me any clue.
That force acting towards center will provide centripetal force.
Everyone clap for Shruti. Net force acting towards center will provide centripetal force. Do you agree? Net force acting towards center will provide centripetal force. So at point A, what is net force acting towards center? How much net force acting towards center?
TA minus mg is equals to mv square.
Very good, very good. TA minus mg. TA minus mg is equal to mVA square by L. Let's suppose this is equation A. At point B. बच्चों at point B, सेंटर की तरफ कौन कौन काम कर रहा है? O की तरफ.
TB plus mg.
TB plus mg will provide mVB square by L. But if we give minimum velocity at A, इसमें लफड़ा हो जाएगा. Minimum velocity at point A, then at B tension must be 0. Why tension must be 0? Tell me. क्योंकि पूरा का पूरा सेंट्रिपेटल फोर्स किसने दे दिया? एंटायर सेंट्रिपेटल फोर्स गिवन बाय mg. और हमें mg को सेंट्रिपेटल फोर्स देने में बिजी रखना होगा, नहीं तो mg क्या करेगा बोलो? अगर if we could not keep mg busy, it will pull block down. Am I right?
Yes, sir.
So at point B mg पूरा का पूरा क्या दे रहा है? सिर्फ
Centripetal.
Centripetal force.
अगर mg को सेंट्रिपेटल में बिजी नहीं किया तो वो क्या करेगा? ब्लॉक को खींच लेगा. तो तुमने यहाँ पे कैसी वेलोसिटी दी है? मिनिमम. तो बी पे भी कैसी वेलोसिटी होगी?
Minimum.
तो जब मिनिमम वेलोसिटी खेल रहे हो तो इसको कहते हैं क्रिटिकल वर्टिकल सर्कुलर मोशन. क्रिटिकल खेल रहे हो ना? तो अब बताइए, तो टेंशन 0 बिकॉज only mg is sufficient to provide centripetal force. Am I right?
Yes, sir.
Finally, I am putting TB 0. So mg is equal to mvb square by L. mm got cancelled. At point B, you got velocity under root gl. समझे या नहीं?
Yes, sir.
Yes.
Transfer L other side. So it's a good news. We got minimum velocity at point B. And it is equal to under root gl. Okay, now where I can put this value?
First equation.
Equation 1.
Let's put this value in equation 1. See what we'll get. 4gl plus VB square. 4gl. VB square is just gl because VB is root gl. We just calculated it, okay? So VA will become 5GL. So what minimum velocity you need to give at A so that it somehow complete vertical circular motion is just it complete vertical circular motion? What minimum velocity you need to give at point A, at the bottommost point? How much minimum velocity you will have to give? Root
5GL.
अगर आप root
5GL.
देते हो तो
5GL.
जस्ट वर्टिकल सर्कुलर मोशन कंप्लीट करेगा और टॉप मोस्ट पॉइंट पे वेलोसिटी कितनी रखेगा?
GL.
GL
और टॉप मोस्ट पॉइंट पे टेंशन कितना होता है?
0
कब किस किस सर्कुलर मोशन में हमेशा होता है या कोई एक स्पेशल सर्कुलर?
Vertical circular motion.
हाँ, क्रिटिकल वर्टिकल सर्कुलर मोशन में टीबी हो जाता है 0. ओके बच्चों, कैन यू हेल्प मी इन कैलकुलेटिंग टेंशन एट पॉइंट ए? Let's put value of VA here. We can get tension at point A. Am I right?
yes
Okay. So from equation A, put VA is equal to root 5GL. So net force acting towards center was TA minus mg and this was providing centripetal force. Do you remember this equation A? इतनी खराब मेमोरी लेके क्या करोगे कि अभी लिखा अभी भूल गए? LL got cancelled. So you got tension at A is 6 mg. Understood everyone?
yes
Yes, sir.
Okay. So that's it for the day. We just started vertical circular motion. We just started. Okay. We'll do it more in next 2 days. Next 2 days we will keep solving questions based on vertical circular motion. And we started with the critical vertical circular motion today. In this we are giving minimum velocity. I believe everyone understood what I did first of all. First of all, I applied conservation of mechanical energy. And step 2 what we did? Step 2 what we did? Read.
What?
Read it.
net
The
force
force
acting
acting
towards
towards
center
center
will
will provide
provide
centripetal.
centripetal force.
Okay. And then we wrote net force equation at point A and at point B. And then we realized at point B, mg alone is sufficient to give centripetal force. So we eliminated TB, assuming it is 0 for the critical vertical circular motion. We got velocity at B. So where we kept this velocity of B? In first equation, so we got velocity at A.
First equation.
So we got velocity at A. Now after getting velocity of A, we wrote velocity of A in this equation. So we got, of course, tension and tension at point B is 0. I hope you all understood this properly. Am I right?
So
I will send you these notes. Please update your copy. Write each and every question in your copy properly. I am sending these notes regularly. I have sent you a lot of questions already. You can try all questions now. You can try all the questions present in that assignment I already sent you today morning. Okay, bacho. Bye everyone. Take care. Bye bye.